All right, folks. Good morning, everyone, and welcome to the presentation. I guess we'll get started now. This is the presentation about Project Nashorn, which is Oracle's new JavaScript runtime on the JVM that we will ship with Java 8. So we still have some time to finish it, but it is already available for trying it out, and we are quite excited about it. So this is what I will tell you about here today. All right, a few words about. So we'll bring up this. A few words about myself. I work for Oracle, and this is how you say that in a slide. My name is Attila Szegedi, and I'm currently part of the Java Lang Tools team. I'm based in Stockholm at the moment, and I'm working on Nashorn and, well, generally in Java platform support for multiple languages. If you have just been at Ben's talk before my talk, then he was presenting the case for polyglot programming on the JVM, and that is actually one of my biggest interests as well, to figure out how to make JVM, the Java platform as such, so just the JVM, but the library support as well, how to make the Java platform more hospitable, or as I would like to have it, the most hospitable platform for running various languages. Before my involvement with Oracle, I used to be I used to be a staff engineer at Twitter. I also, in the past and currently, I'm involved in several open source projects. Now, obviously, I'm involved with Nashorn, which is an open source project. I am involved with another thing that's named Dynalink, which is a little bit like the DLR on the .NET, and I will actually spend a few words on it. This is again well within the story of interoperability between different languages on the JVM. At my time at Twitter, I was working on Kiji, which happens to be a Ruby runtime, which is actually the original C-based MRI, Maths Ruby interpreter, except that its memory management really didn't scale, and if something doesn't scale, you figure that out really quickly at Twitter. So I was one of my first things when I went there was they threw me in the deep end of the pool and said, well, you would need to rewrite the memory management of this thing in C. It was fun, the kind of a fun when you try to figure out why various parts of the memory stomp on each other's feet and use GDB hardware breakpoints, because if you happen to have a bug in your memory manager, then these things are bound to happen, right? You either have a memory leak or you have two parts of the program thing that they both own that particular part of memory. Again, case in point, if you write your language runtime on the JVM, this is just one of those things that you definitely won't have to worry about. In previous life, I was also responsible for probably good 1/3 of the code base of the FreeMarker template engine. As you can see, the underlying theme here is no matter what open source project I work on, it turns out to be a language runtime. I might just as well accept the fate. So what is Nashorn? That's Oracle's new JavaScript runtime, although I always feel like I'm cheating when I say JavaScript runtime. So although it's much harder to pronounce, it is actually an ECMAScript 5.1 runtime. There are subtle differences. We'll get to that. It is GPL licensed, as everything in OpenJDK is. It is part of the OpenJDK. The source code lives in the OpenJDK repository as its own little mercurial forest, and it is slated for Java 8 release. Actually, you can even get it right now if you get the latest early access builds of JDK 8. Nashorn is there. So, why does Oracle develop a JavaScript engine. We would like to think that we primarily do it because Atwood's law seems to be absolutely true. Who knows what Atwood's law is? All right. So Jeff Atwood, the founder of the Coding Horror website, is famous for his law, which states every application that can be rewritten in JavaScript will be rewritten in JavaScript. And so if we do have a JavaScript runtime, we are providing a platform for an increasing fraction of the world's applications to run on. Also, this is Oracle's own proving ground, or in some other places you would say dog food for Java platform support for dynamic languages. Java 7 introduced the invokedynamic instruction, but nothing in the platform really used it in Java 7. Now in Java 8, there is something that uses it. Actually, there's two things. Lambdas do use invokedynamic, and Nashorn also uses invokedynamic. So we, as we are implementing Nashorn, we are running into well, various degrees of pain, mostly in the performance area, and then we can go to the hotspot team, throw them a test case and say, please fix this, and they do. So we are basically acting as a driver to ensure that when Java 8 ships, that invoke dynamic performance is actually what you would expect it to be. Nashorn is also designed for secure execution. This is not a really obvious aspect of it, but it is super important. Since Java 6, the Java platform has a scripting API, a standardized scripting API. And at that time, Sun took Mozilla Rhino, an open source project, and put it into Java 6 as the default implementation of a scripting API. So you don't just have a scripting API, you do actually have a scripting language that you can already use with it. Unfortunately, Rhino is an incredibly old code base. I'm not bashing Rhino. I used to be the administrator for the project for a while. The project is still somewhat dear to my heart. But it was never designed for secure execution. Its code base actually predates Java 2, which introduced the modern security architecture in Java. And so we have a code base that was developed without secure execution in mind. It's shipped with a JDK. Every code that ships with a JDK runs privileged. Bad things might happen. Bad things did happen, as you might have heard in the news in the past. So with Nashorn, we are incredibly sensitive about that. Our tests, all the tests that we run under the security manager. So, and we have specific tests for privilege escalations and so on and so on. So again, of course, I mean, security is one of those things that you can only be certain that you got it wrong when it's breached. But we are really doing a very conscious and concentrated effort to write this thing from the scratch so that we are paying attention to Java security infrastructure. Anyway, the other thing is, okay, so we have Rhino. Why not just try to re-engineer Rhino? Well, the other thing is, Rhino is also backwards compatible with every JavaScript version in existence going back to 1 point, whatever is the earliest. And we decided, go with ECMAScript only, and we don't want backwards compatibility baggage with that one. That is the modern JavaScript version anyway. Basic differences from Rhino. All code is compiled to bytecode, fed to the JIT, eventually ends up being JIT compiled to machine code. There is no interpreter. Rhino used to have an interpreted and compiled mode. One neat thing is that in the interpreted mode, since it was actually handling its own stack frames, Rhino had a feature for first-class continuations, which could be nice if you were doing things like continuation-based web application frameworks or some other crazy stuff. I actually used to earn my living building mission-critical systems that were running tens of thousands of scripts in parallel using continuations. So it was nice to have, but obviously if you compile to bytecode, you can't have it. You can't have even tail calls, right? Another thing, there is no separate public API for Nashorn. There is no JDK Nashorn, whatever that you should use. You only use it through the Java-JavaScript APIs. Also, we only implement ECMAScript 5.1. We do implement it 100%. This photo was taken this November in a bar in Stockholm. This is actually my machine. If you don't see it, it basically says the ECMA 5.1 test suite has some 11.5 thousand tests that pretty much reproduce every clause in the specification, and that there is 100% and failed 0. For about a month and a half, we had failed 1. And as you have those things when you sometimes have one failing test and it uncovers a really fundamental problem with something in the architecture of your implementation, I think I worked for a month and a half to get to from 1 to 0. That also explained why this was, I reached this in a bar in Stockholm, because that was one of those things when I was running a test and it was 6 p.m. and everybody was eager to leave the office, and I said, okay, this will be done in a moment and we'll see a 0. And then it ran and it showed 1. And I said, all right, okay, pack the bags, go to the pub with the others, and then I just, as geeks are wont to do, broke out my machine and then fixed it, rerun it, and yay. And I believe we are actually the only JavaScript runtime in existence that's 100% compliant as of now. So where is it? It ships with Java 8, started from B82. Oh, sorry about the release yesterday. That was true on Sunday when I was giving a short version of this presentation as well. If you go to your Java home, in the bin directory, aside from Java, Java-C, and other applications, we have a new, nice, curious little program named JJS, and that's it. The code itself lives in the extension directory in nashorn.jar. All right, how does it look like, okay? So how do you use this thing? Simplest way to use it to call from Java to JavaScript is something like this. That's not much really to this thing. This is not Nashorn. This is a short course in using the JavaScript API, because that's our public API. You create a script engine manager. You ask it for an engine by name. Name is Nashorn. And then you evaluate something. This, in this case, is define a factorial, invoke it for 5. You know, doesn't really get much simpler than that. And just to show that this thing actually does run, well, hopefully it is, if demo gods are with us, then we'll, yep, there you go, not terribly exciting, but hey, it works. All right. It's usually not terribly nice when you have something and you need to evaluate a string all the time. You feel like there will be parsing, compiling, everything going on in the background. This is not terribly efficient if you need to execute something multiple times. Java-JavaScript has this invocable interface that you take the engine, you evaluate some script in it, it will define you functions in its namespace. And then if you cast it to this invocable, then you also have this invoke function method on it, when you can just say invoke f, pass it these arguments. I was being cheeky here because I'm actually passing strings and relying on the JavaScript fantastic type system, which will convert any string that is parsable as decimal number into a decimal number when that's required. So, hey. Okay. Again, let's run this guy. Yep. Seems to work as advertised. If somebody wants to confirm that the factorial of 10 is indeed 3,006,000, 3,006,000, 28,800, then I didn't confirm that. So it's buggy. Well, you can also use the scripting API to implement interfaces. If, for instance, you have a function named the run. I was told to not go outside from the desk because that's where the camera points to, but I will be bad. So function runs will just print the next factorial. It actually maintains state, so you have a variable there. So this function actually works as a closure around the external context. So when you, for the invocable, you say get interface runnable, it will actually look to see whether it has a function named run in it, in the script, and will give you back an implementation of runnable that just delegates to that function when invoked. And if you invoke it 3 times, we should get the factorial for 5, then for 6, then for 7. Alt-tab is working weird. All right. Yep. As you can see, that's what it says on the tin, and preserve the state between the invocations. And of course, when you do it this way, then the function is evaluated once. At that point, it is actually compiled to the bytecode. So when this runnable is bound to the function run, it will actually be immediately hooking into a compiled bytecode method. So no further interpretation or whatever else happens at that point. You can also pass variables from the outside. Obviously, I mean, invoking scripts is fun, but if you really want to do something more involved, then you will want to be able to pass variables. The way you do it with the Java-JavaScript API is you have an object named bindings, and you can take your engine, you can create bindings. It usually has its own global bindings, but if you don't want to have too much of namespace pollution, you can just create another one, and then the eval actually has a version that takes a binding object. And in this case, we are just constructing a file that points to the root directory. We are not running on a security manager. That's why we can do it. You just call list files, and then at the end, we just retrieve the variant. We just retrieve the variable, as you can see. So again, these are really, really small examples, but I don't. They represent, they're meant to illustrate the concepts. And, well, yeah, this does look like a Mac root directory, right? Sort of, wow, there's a lot of hidden stuff. So as you can see, we could invoke a method on Java, on a Java object that was passed from the outside, and assign the return value to the variable, and we could dig it out on the Java side. Okay, so we stop here for a moment because I am not trying to give you a full tour of the JavaScript API. I think I had presentations about that back in 2006 or 2007, so this is pretty much ancient history. The point of all of this is Nashorn is just JavaScript. It just works as JavaScript runtime, and we could say at this point, okay, well, thank you for your attention, you have an early break. That was all, except it isn't. Because there is obviously one big discriminating feature of Nashorn when compared to any other JavaScript runtime, and that is the thing actually runs on the JVM. So we do have a bunch of additional functionality for actually interoperating with the platform, and that is these are the interesting parts, right? So you can run anything JavaScript on it, but the real interesting parts of this runtime are where you can actually work with Java libraries. So the way it manifests itself is, well, as you could expect, right? You can create Java objects. You can manipulate them in a sense that you can set, get public fields, get properties, set properties, invoke methods, the whole deal. You can extend Java classes and implement Java interfaces from within the script. It is actually a little bit hard to talk about this because the obvious idea is to make this thing as intuitive and straightforward as possible so that every slide doesn't just end up with something when you go and say, well, duh, yes, of course. Okay, however, let's see an example. This is actually a really nice example because it illustrates several concepts. In this example, we will create a timer. We will schedule a timer task in it to run once every second. Then we'll pause the main thread for 5 seconds to give the timer task guy a chance to run for a little bit, and then we'll cancel the whole thing and exit. I have this here. And is, same program. And, you know, as you would expect it, it does what it should. Ticks 5 times, maybe 6 times, and exits. All right, so let's see. First line, we say new Java util timer. First concept, you can address Java classes because we do actually provide few top-level variables, for instance, lowercase java, which is the start of the Java package. And if you retrieve a property util on it, then it will be the Java util package. And if you retrieve a further property on it named capital T timer, you will get some representation of the Java util timer class. This representation, this type object, allows you to do funny things with it. For instance, it acts as a JavaScript constructor. So if you do a new on it, you will indeed get back a timer, an actual Java timer. Next thing we do is we invoke its schedule method, where you can see that we can invoke methods on POJOs. And what we pass to it is new Java util timer task. The resolution of Java util timer task is the same as it was for the Java util timer. However, as you well know, the timer task is an abstract class, so you cannot just instantiate it. On the other hand, what we do here is we pass an object literal to it. So we are actually doing what this does is extending the class. As a matter of fact, this could be rewritten so with the Java syntax, where you just say Java util timer task braces, and then you put the curly brace on the outside, just as you do anonymous inner classes in Java. That is actually a syntactic extension that we support, but I personally don't like it so much. So really, you just pass the object literal as the first parameter to the constructor of the abstract classes. We extend the constructor so they accept the first argument to be the last argument to be an extension object. And there, the literal has a property named run, which is a function, and then the Nashorn's machinery knows that what we want to express here is that we are extending the timer task and providing an implementation for the run function. Okay, quite clear. It doesn't look terribly bad, but we can do better. This is a shorter timer example. Okay, so what happened here? I'll cycle it a few times. What happens here is that we got rid of the object literal. There's no longer an object literal. The argument that we are passing to the timer task constructor is just a function. We don't even bother giving it a name. What happens here is that Nashorn was written as to be as smart as to realize that the timer task only has a single abstract method. So if you pass it a function, chances are you want to provide an implementation for that one single abstract method. This works with interfaces. This works with abstract classes that only have a single abstract method. So this is even shorter. It works exactly the same way. It can be even shorter. All right, so this one is really funny. What happened here is that we don't even bother mentioning the timer task class anymore. Where is it then? Well, it is implicit. It's we invoke the schedule method on timer, and we know that this guy actually expects to receive a timer task. And then we see that this is type conversion, right? We need a timer task, we got a function. All right, can we meaningfully interpret this function as a timer task? Is timer task by chance an interface with a single method or a class with a single abstract method? Oh, yes, it is. Excellent. Then we'll just create a proxy in situ and say this is its implementation. So in case we are using the available static type information when we can. So since we know that when timer.schedule is invoked, we will see at invocation time that, hey, schedule requires a timer task. We got a function. We'll just construct what needs to be constructed around it. You can see this in action quite nicely. This is my timer 3 example. I also have the timer 2, but I won't run it because it really is the same. Here's the timer 3, and this we won't need this in it for now. All right. And if we run it, you know, it works just the same way. if you want to see a little bit under the hood, what I had here before is I created an exception and printed its stack trace so that you can see how does the execution actually get to this point. If we run this now, you will see how we are in the timer thread's main loop, and this is the compiled code of the function itself. You see it actually has source and line information. And this here is the adapter, as you can probably guess from the very long name. This is the dynamically generated adapter that we create on the fly for timer tasks. As a matter, we are being very, we are dealing with code generation very sparingly. We will only ever create one proxy class for all timer tasks. And then when we create instances, they have fields where we just plug in the function that needs to be invoked. So even if you do several different subclassings of the timer tasks out your code base, this will actually only trigger code generation once. So you don't have to worry about it being too expensive. All right, what else can you do in Java? Well, let's see, how would you construct an array list? You can do the thing that we did with the timer task, doing java.util.arraylist. Or, since in JavaScript, every expression is pretty much a first-class object, you can just take this Java util array list and you can assign it to a variable, and then subsequently you can just say new array list because it will refer back to that variable. Because when you say Java util array list, each dot is actually a property access, right? So this is obviously faster. And then there is an entirely different way. We provide an object Java with a capital J, and this is actually the preferred entry point in the Java integration in Nashorn. We would prefer if every Java integration that operation that you explicitly use would actually go through this. It gives you the type method, where you just specify a type name as a string, actually, and you get back, again, an object that represents that type. Why would you do that? I mean, why is that better than the one on the top? There are several reasons for why is it better. For one, it doesn't do a bunch of property accesses, and the other is, what happens if you mistype the thing? So if you, you know, or get carried away with a bit of a pirate feeling and you get another R in your array list. If you use this program, this array list, and I believe I do actually have it here. No, that's not the one, but yeah, you know, let's do it. Var array list equals Java util array list, and then you try to just do a new one. You will get this really not helpful error saying Java package Java util array list is not a function. What? So here's the thing. Packages don't exist in the JVM. They don't, all right? There are no package objects. They're never reified in the JVM. Only class names exist in the JVM. Packages are pretty much, from the point of view of the JVM, for better or worse, they're just an illusion. So when you write java.util.arraylist, then the machinery has to say, well, I don't have a class with this name, but you know, it might be a package name. I have no way to verify it, but I will have to assume that it might actually be a package name, and maybe somebody will try to further resolve it. So that's why. On the other hand, if you do this, then at this point, you see that this is a fully delimited class name. There's no question whether we want this class. We will never assume this is a sub-package. This is a full string, no other pieces. And if I run this now, I get a much better exception. The thing that you would expect to see from Java as well. You do get a class not found exception, which at least clearly tells you what's going on. And no, we couldn't do that with the other syntax. So there is another reason why you should use java.type. This here is how you can create an array in Rhino. In Rhino, you typically had to use this to create an array. So you would say, you want an int of 5 elements. You say java.lang.reflect array, a new instance of integer type, and please give me 5. So in Nashorn, Java type, since it receives string arguments, it does actually understand primitives, and it does understand array notation, so you can actually write this in a much more compact way. And since the Java type actually returns you the type object for something, you can just extract it into a variable and then use that afterwards. It's much nicer, it's much shorter. All right, why we are talking about arrays? What happens when we assign stuff to an integer array, right? So let's create an integer array with 6 elements and then start to throw stuff in it that are, well, not integers, right? Okay, the first one is, so assign 1, fair enough. Let's assign a double, 1.6. Hey, let's throw null in it. Or what if I throw the string 45? What if I throw the string foo? What if I assign undefined? So, after all of this, let's print it and see what we get. We will get what you see at the bottom. Does it look correct? Well, it does not. I mean, I cannot say as a programming professional that the result looks correct. But the ECMAScript specification says that the result looks correct because it followed the JavaScript conversion rules from anything to integer to the letter. Null converts to 0. Undefined converts to 0. The string foo converts to 0. On the other hand, the string 45, if it represents if it's a string that represents the decimal number, then it actually has to be converted. Oh, and doubles are truncated, of course. So, yep, this is how it works. If you do this with doubles, then the situation is slightly better because, well, for one thing, 1.6 will be faithfully preserved. Null converts to 0. Yes, that's correct. Well, that's correct if you are the JavaScript spec. 45 will again convert to number 45. Interestingly enough, the non-convertible strings and undefined will be translated to double, not a number, which, as far as things are considered, is actually pretty good. I would really prefer if null converted to not a number as well, but again, the specification says it's 0, so we have to go with it. So type conversions, how do type conversions generally work? So you saw that when we were passing a JavaScript function to a method that expected a timer task, we did actually convert it to a timer task. We don't do a lot of these things. We do these things for this kind of a function conversion where it's sensible. As you can see, we will use all the Java method invocation conversions plus all allowed JavaScript conversions. So if your Java method that you invoke requires a string and you supply it a number, we will convert it to a string without blinking, other way around as well. If your Java API requires a map and you pass it a native JavaScript object, you will pretty much just get the object because as it happens, they do implement the map interface. That's actually pretty nice for the sake of Java interoperability if you want to manipulate your JavaScript objects on the Java side. Then there was the day when I had the great idea, hey, if native objects implement map, then our native JavaScript arrays should also implement list, right? And it was great until I realized there's no way you can implement both list and map on a single class in Java. And that is because map has a remove method that takes an object and returns an object. And lists have a remove method that take an object and return a Boolean. Oh well. And obviously in JavaScript, arrays are objects. So a native array is a subclass of our native object. A native object is already a map. And that's why our native arrays cannot be lists. Maybe we'll introduce some adapter further down the line, but there's there is a really unfortunate reason why we cannot do the obvious thing, just implement the list interface on it. And that's because it cannot be a list and a map. Oh, and before you ask, a JavaScript array has to be a map because you can actually shove arbitrary properties in it as well. So arrays. So what if you define a JavaScript array and you have a Java API that takes a Java array? Will we just convert it automatically? Yes, well, no. No, we won't. It would be a terrible idea. Why? JavaScript arrays can change their length, can grow just as lists can. They can hold arbitrary types, so typing would be quite interesting. Oh, and they can also be sparse. So there is no automatic conversion that can preserve all these properties, and especially two-way. What happens if that array then gets mutated in Java, and you would expect to see the effects on the outside? So we are not doing any explicit conversion there, because no matter what conversion we would do, somebody will get surprised. So what we do instead is we provide two functions, two APIs on the capital J Java. One converts from a JavaScript array to a Java array, and the other converts the other way around. The one that converts to Java array can optionally take a type, so you can tell it what kind of an array you want to. Incidentally, if you incidentally, actually, I do actually have a small. Yes, here's a little program. I will reformat it to be a little bit more readable. So this takes an JavaScript array and the name of a type, and then it basically just prints it. It has to run it through Java util arrays to string. It uses our Java to Java array method, and we can. It's an MD5 or something or the other that accidentally got in there. So here we have a sparse array, and we convert it to an primitive array of ints. Then we do the same thing, but we convert it to integers. And then we look at what happens with the nested arrays. So this is an array of arrays, and we convert it to an array of objects. So it was named Java array. Ooh, let's save this. All right, so in the first case, the undefined, well, really null element of the Java array, when we convert it to a primitive int, will actually become 0. As you can see, in JavaScript, that array does not actually have the element number 1. It doesn't exist. That array is sparse. When we convert to an array of capital I integers, that element will actually be null. Again, they cannot remain sparse, right? And in the third case, you actually get an Java array. One does not work because the code that's generated is just too large, and the Rhino does not have code splitting capabilities. Oh, there we are. But we do. So as you can see, I normalized these tests for Rhino. So Rhino is always 100%. It's the blue one, and Nashorn is the green bar. And as you can see, on most of those tests, we get between 2, mostly 3 times, and some of those tests actually run about 5 times as fast as Rhino does at the moment. And I should add, we hardly did any performance optimizations yet. My last 3 weeks or so were mostly spent doing some compiler infrastructure rework for Nashorn that leads to some other of my colleagues being able to hopefully write type specializing code generation, where we can, if we have a function and we have at some point, at some call site, we can prove that this function is always just invoked to integers. We can just generate a function version bytecode that runs with this assumption saying, hey, my parameters will always be integers, and then propagate that as far as it can, hopefully being able to just run with that all the time. Right now, we do what's reasonable if a local variable in a function is not used by any nested function in it, then we will just stash it in a bytecode local variable, so we are not creating scope objects all the time. In some situations, already within the function, we can determine if it's assigned a number and it always remains a number. Surprisingly, not surprisingly, a lot of operations actually blow up the type2 object, so this usually doesn't get too far, but you have shift operators, binary arithmetic, and some other things actually do preserve the numberness of the value. So if you have a heavy number crunching function, it can actually interestingly preserve itself. We can already load and run fairly large scripts. We run the SunSpider benchmarks. We can parse and load jQuery, underscore, all the Octane benchmarks. The PDF.js Octane benchmark actually produces huge code, and as you may know, JVM has a 64K limit on a single method bytecode. We do actually get around that, so we wrote some, well, not me, but some smart people on the team wrote a very impressive control flow code splitting machinery that so far works for everything that we threw at it. And we are throwing at it weird stuff, like things compiled with ECMAScript. ECMAScript, in case you didn't know, is an LLVM backend for JavaScript, which means that you can take a program written in C and you can compile it to JavaScript. All right, I'm aware, we'll be done. And if you go, for instance, to playttd.com, you have Transport Tycoon in a browser, which is really, really nice. It runs on Chrome. It does not run on Nashorn yet, but since we are big in Transport Tycoon fans, we would really love to get it. Of course, for that, we would actually need to have some HTML APIs, like Canvas, HTML5 Audio, WebGL, Web Workers, and so on. We do not provide these. We are like V8 is. We are a core JavaScript runtime. Everything else needs to be built on top of that as an environment. Well, you know, this thing is open source. Feel free to treat any of those as a challenge. If you write it, we'll take it. I mean, WebGL, right? There is also OpenGL bindings for Java, JSR 231. I think it would pretty be a fairly easy layer on top of that, a fairly easy binding. And why I'm saying that we are an ECMAScript runtime, not a JavaScript runtime, is that JavaScript is a Mozilla's extension, usually to ECMAScript, which gives you things like generators, destructuring assignment, and so on and so on. We do not currently have those, although we might. We do actually want to have those. Again, didn't promise anything. What else is there? We have cross-language communication within the JVM already, because, in case you noticed, we have a JavaScript that talks to Java classes. This mechanism is generic and is embodied in a library that I maintain named Dynalink. This is somewhat similar to the dynamic language runtime on a .NET, and right now it's buried in Nashorn, but I'll be working in the future to bring it up and make it available for other languages. That's part of my overall direction of not working only on Nashorn, but generally in support for dynamic languages on the JVM. Also, what we also have, we have an in-house. It started as a proof of concept Node.js port, like the ultimate killer application these days for any JavaScript runtime is Node, apparently. Well, and even for non-JavaScript runtimes, because they're porting it to non-JavaScript these days. We have few people that work on porting the Node.js port. They took Node.js, forked it, threw out the parts written in C, and replaced them with parts written in basically the equivalent APIs, networking, and so on in Java from the standard Java library. It works really well. We are quite excited about it. They even got it to run on a Raspberry Pi using the ARM JVM. I mean, how cool is that? And we like it a lot, and we really hope to be able to give this thing to you really soon. It's not open sourced yet, but you know, we're working on it. It would be a real killer application. If you want to get involved, there's the repo, there's the project main page, there's the mailing list. These are your starting points. And that's all I had, and we still have 1 minute for questions and answers. Well, thank you for your attention, and I'll take questions. Yes? Yes. Okay, so the question was, what is the debugging experience when the when we have bytecode generated from JavaScript classes? Then can we step into those? Yes, you can step into those. I'm reluctant to try to show you because I'm not sure whether it would work now, but we do emit the full expected debug info in the class file. So we emit the file name, we emit the line number, the symbols are there. So for all the local variables that we emit all the symbols as well. Jim Lasky, our team lead, one of his bigger side projects is actually writing an additional debugging support. But the raw debugging does actually work. Depends on your IDE, whether it is finicky and it says, oh, this file name does not end in Java, so I will not let you put a breakpoint in there. But it might just work. If you want to, we can try it during the break. All right, other questions? Yes? Yeah. Yeah, we are slower than V8. Depends. Several times right now. I don't have current performance benchmarks for that. We don't really want to compete with V8 at this time. Those guys have the obvious advantage of having a virtual machine that is specifically written for JavaScript, whereas the Java virtual machine is written with the idea of classes with static layouts, 5 types, int, double, float long object, right? And I mean, sheer number crunching performance, they will always beat us. I don't really have too many illusions that we can actually achieve their level of performance in sheer number crunching. But you know, there is a bunch of other applications, as Node.js and so on. These things are usually IO bound, and etc. So you know, I think we will be supremely good use cases for that, especially with all the Java library integration that we have. But yes, we're slower. But again, I'm actually really, I'm not terribly worried about that. I think we can get to, well, again, I really don't want to, because the problem with performance numbers is they get stale really quickly, right? I tell you a number now, it will be completely obsolete 3 months from now, but people still quote me for it. So, so that's why I'd rather not. It's, yeah, we are slower. We are not making an issue of it. Yes? Was there any other question? Yes? Right, this is an excellent question. The question was, if you implement an Java interface or subclass Java method that has overloaded methods with the same name, how do you implement them? Well, JavaScript does not have a concept of overloads. So an object has a property with a given name. If it's a function, it will handle all the calls for that function name. And we do follow that. So all the overloads will be mapped to that function, to a single function. And it will be your job as the implementer of that function to pay attention to the arity and maybe the types. You will need to do a dispatch there because we will basically multiplex all the overloads on that one function. This is actually quite funny because what if you have an abstract method with a name and you have a concrete method with the same name? We chose to say you will override both of them. That's, I mean, that's a design decision, and I stand by it. But yeah, that's an excellent question, actually. All right. Okay, I think we are out of time. So thank you again for your attention.